4, 3, 2, 1.
Hit it. Experience 24 hours of head-to-head AWS sessions from around the world.
Mic check, 1, 2.
Jaws PANKRATION 2021. Up till down.
Hello, everyone. Thank you for joining this talk. I'll be talking about operationalizing MLOps on AWS. I am Joinal Ahmed. I have a couple of years of experience in building and maintaining machine learning operations platform on AWS and other multi-cloud environment. Going ahead, let me first talk a bit on machine learning lifecycle. It starts with sourcing the data, where we have data engineers and other people helping us to do that, bring the data from different sources into storages so that the data scientist can then go ahead and start using. The second step that comes is exploration of the data and then doing some analysis, learning from the data. Then based on these learnings and exploration, we transform the data, maybe merge multiple databases or merge multiple data sources to combine and have a final data source. Then while we do all this, we also look at like scheduling automation for periodic data dumps, periodic data analysis, and transformation jobs. Once this is done, we then dump the data to a feature store so that it can be used for all downstream data modeling and evaluation use cases. Then once we have the data in a feature store, we then go ahead, build our data, build our models on the data. And once we are satisfied with the model, we can do multiple experimentations, deploy the model to server. And this experiment continues, right? But the problem here is, since there are a lot of repetitive steps that needs to be done, we need a platform or a way to manage everything and orchestrate everything. That is where an MLOps platform comes in. It helps us to automate everyday tasks, get more visibility around the work, and also it allows to maintainability and reproducibility of the experiments. Key components of an MLOps platform. To start with, we should have a version control for model code, data, and experiments. Then we also need a secure network layer where the security engineers come into picture. They help us to secure the data transfers. Then based on the ML loads, for example, in AWS, we have AI services like Lex. We have Lex. We have recognition. We have translate. So these are AI services, and anyone can start using it. Then we have ML services, which can be then used to build models and build solutions around it. And experienced and users, they can go ahead and use ML frameworks and build their own models. Then the next thing come in is as an adaptation of infrastructure as a code for automating and to provision these resources for machine learning workloads. Then machine learning training or retraining pipeline. An orchestration tool which helps us to manage all of these together. Along with it, there are concerns around model monitoring, data drifts, where because it is expected that the model is going to change the data distribution later. So model monitoring is important. ML governance is important. Then to help us build and deploy this model faster, the data platform is also required, which helps into retrieving, storing of the data. Let's take an example of an solution where the idea is to build a platform where we can analyze the social media data that people tweet. For example, let's take this event. There are a lot of people tweeting about this event. We can then build a pipeline. What we will do is we will look at all of these tweets, and I try to identify the positive and negative sentiments about the talks that are happening. We can also look at what went well, what went wrong from these tweets. A simple way to do it is we'll have a job running on an EC2 instance, which will listen or which will just scrape the web, Twitter, Facebook for related tweets or comments, messages. And it streams these raw tweet data via Amazon Kinesis data firehose. What this does is Firehose streams the data to an S3 bucket. Firehose streams the data to an S3 bucket, and we can then have on S3 bucket on S3 bucket we can then have this event listeners that triggers an lambda whenever a new tweet is dumped on a raw folder. And what this lambda function does, it calls Amazon Translate because people will be tweeting in various languages. So we can translate everything into English or Japanese. And also once it is translated, Lambda will then call Amazon Comprehend, and it will extract the sentiments and entities from that tweet. Once this data is in the buckets, this is a real-time pipeline. As soon as a tweet is done, our job running on an EC2 instance listens it. As soon as a tweet is posted, the job running on EC2 instance listens to it, streams the data to S3 bucket via Firehose. A Lambda function is triggered. It calls translate and comprehend, extracts the data and stores it in S3 bucket again. Now the event organizers then go ahead and use Amazon Athena to query this data, and then use Amazon QuickSight to build a dashboard which shows the positive, negative sentiments and all the comments of the users. This is a very simple example, but the thing here is there are a lot of components that needs to be redone every time we build a new solution. This is why we need an MLOps platform, which helps us to use repeatable components multiple times. This is an architecture of an recommended MLOps platform. It has various tenants. If you see here, data science team uses it actively. But also we have data engineering team pushing the data to train the models. DevOps or site reliability engineering team, which maintains the platform. And there are data architects, ML architects who manage the whole platform and make sure it runs effectively. To start with, data science people, they work on Amazon SageMaker notebooks. And once they are happy with the experiment and do a code commit, it creates a SageMaker Docker container on the fly and saves it on Amazon ECR. Now the data scientist can then go back and again start a training pipeline on Amazon, like using Amazon Lambda. And what Lambda does is it calls the Amazon image from Amazon ECR. It pulls out the data from the training, data store, feature store, we can call it. It can be an RDS instance. It can be an S3 bucket. It can be an feast. Now, once it pulls the data and the image, it can do data validation and start training. While the model is training, we can check for all the hyperparameters and all the metadata. And once we are satisfied with the experiment, the model is then stored in an SageMaker model registry. And based on certain rules, let's say if a new model is based on certain rules, if a new model is performing better than the old one, the model is automatically deployed, and this can be done using an CloudFormation template. What it does is it exposes an Amazon SageMaker endpoint for the model, and on that we'll have a job to monitor the model, its performance, how the model is predicting, latency and everything. And all this data is logged into CloudWatch, and on CloudWatch we can have alarm to detect model drift, data drift, and other performance issues. And from one side, what data engineering team does is they have they can use managed Airflow on AWS to orchestrate their data ingestion pipeline. And once the data is ingested, they can do repetitive feature engineering and labeling tasks. And the finally created and clean data is then stored in a feature store. And the SRE team manages the whole security aspects of it, how the infrastructure is provisioned, and if needed, they use infrastructure as a code, or the tools like Terraform to manage the whole platform. This is it. A detailed description of the whole platform is in this given link. All the interested people can go ahead and read it out. And there are also a few references where if you are interested in operationalizing an MLOps platform, you can refer. Thank you. I can be reached out in these on my email or LinkedIn, and I'd be very happy to help you realizing your MLOps platforms. Thank you.
Music's loud and I'm feeling alright. In slow motion, baby, it's just you and I. Yet the burn makes you feel so alive. I'm living the moment till you don't live tonight. We're here now, let's party together. Let's live life, tonight is forever. We're here now, let's party together. Let's live life, tonight is forever. Let the rhythm move us, yeah baby, take it too far. You're at the center of my attention, yeah you got me so lost. I love the way that you move.